got to the end. Remind me about Sean and why he doesn't do taxes anymore by himself. I'll tell you a great story about that. Similar, very similar. Actually, it's better than similar. It's exactly the same story. But I should have known better, and I didn't. All right. I don't know. We're going to do it together. Okay? Oh, camera. Sean, camera. Always forgetting this, Jordan. All right, we're going to go that board zoom in. All right. Okay, you badasses. That's right, you. So. What's that, badass? It can be. It can be. But badass is one of those 80s phrases. Like, badass is a good thing. Language is weird. Language is weird. Okay. We know we're starting with $100. Start with $100. Right there. We are then going to multiply it by the rate. Now that rate is 1 plus R, like it was yesterday. Now 1 plus R made a lot of sense yesterday because we didn't know what R was, so it was good to put that 1 plus R. So I'm going to put it again. 1 plus. What am I going to add to that? Be careful with it. 0.04. Be really careful because that stands for 100%. That means it's decimal form, which means that has to be in a decimal form too. Yes? Yeah. Thank you, dear friends. To the 10th power, because we've lived in it for 10 years. Now, what this will do, we can do this because we figured this out on Tuesday. This is how money inflates. This is inflation, but it's good inflation. Because the money that it's inflating, you get to keep. It's in your bank account. This isn't the economic money that's going into the taxes or whatever. I mean, you probably have to pay taxes on your interest a little bit, depending on how much you make. But you get to keep this interest. So all you got to do now is input this into our calculators. And this is where I like to use Google. I like to use Google and things like this. Because you can type the entire thing in and press enter, and there it goes. We are going to learn Desmos in the next exam, I promise. Because Desmos looks better. You can do these in Google every single time. You can. But I'm going to show you Desmos too. Mostly because Desmos is going to be nicer when we get to next week's stuff, when the equations get a little bit more involved. All right, let me swing this around. What you got, Joes?
So, is it going to be sort of confusing? Okay, so it's $104 after the first year with that interest. Right?
Oh, I see what you're doing. Oh, I love that. So you're going like year by year.
I mean, I did both versions. But,
yeah.
So when we do the next one for year 2, is it doing the percentage?
On 104?
Yeah.
Oh, absolutely, girl.
It is. Okay.
Absolutely. May I, real quick? Josie just asked a great question. I want to answer it in 45 seconds because I think we can, without actually doing the math. I'm going to swing back over here.
We're trying to not do the math.
Say that again?
We're trying to not do the math.
Well, we're going to let it do the math. We're going to let the equation do the math. See, here's the thing about financial equations. They're called iterative. They're nested. You've got repeated calculations happening, and it's all about that exponent, Joes. So what this really means, dear friend, I'm going to write this out, but you don't write this out. We looked at this yesterday in the warm-up, but in case it didn't imprint yesterday in the warm-up, what this means is start with $100, then multiply it by 1.04, then multiply it by 1.04 again, then multiply it by 1.04 again, then 1.04, and you keep doing that until you have multiplied it by 1.04, how many times? 10 times. Joseph, there's your $104 right there. Then you take your 104 and multiply it by 1.04, which you get a little bit more of a nasty number. Then you take whatever you get there and multiply it by 1.04 again, kind of a nasty number. Then again, and you keep doing that until you've done it 10 times. But here's the good news. You don't have to do this. That does that for you. Order of operations says exponents happen first. So it's taking care of it for you. All you got to do is key it in correctly. Is that fair? Let's key it in correctly. Let's do it. After I swing the camera. And zoom it out. All right. Here we go. 100. What if I can use dollar sign? Let's try. $100. I'm gonna put the dollar sign on there and see if it likes it. Let's see if we can break Google. It's always fun to try to break Google. Times 1 plus 0.04. Type it up there in the top. See it up there? I got to raise to the 10th power. How do I do this?
A little carrot.
Say that again, Hannah.
A little carrot.
The little carrot. We learned this. It's been weeks. We haven't seen this since like week 1 and week 2 with the fundamental counting principle and those huge numbers we were looking at. But it's a little carrot. Exactly right. On my keyboard, it is above the 6 key. So oops, not the end sign. Little carrot right there. Cool. 10. Are we ready? When you're ready, go. We're going to have just over $148. That is not what? Oh, sorry. I was trying to figure out what the implication was, if it was good or bad. So Hill I Am just said, that's embarrassing.
Yeah.
You've waited 10 years.
You get 150.
You've waited 10 years and you made $50 in 10 years. That's embarrassing. Kiana, you're agreeing, right? Can we think of it a different way, dear friend?
Okay.
Think of it a different way. Let's think of it percentage-wise. It's $50, which is awesome. We also added 50% to what we invested. So let's play with some numbers real quick. Let's suppose instead of putting $100 in this account, the kid put $1,000 in it. Okay? So I'm gonna go back up here and add a 0 right here. Is that okay?
Yeah.
Notice you added a 0 there too. Because it's exponential. That end result is 50% more than you put in. Now, still, over 10 years, that's embarrassing, right? Which is why this is helping us understand the math of what is called, these are called compounding interest. We're going to do repeated compounds on Tuesday, where we don't just invest once, one time. We invest repeatedly. How many of you take small amounts of your paycheck and put it in the savings accounts right now? Some of you probably do it. Exactly. You don't put a dollar amount into your savings account when you start a job and then never contribute to it again. You do it repeatedly.
I don't think I can.
The math on that is much more complex, so I'd like to start with this. But it really depends, Hill, on what you put in. If you can put, say, $10,000 in, like you inherit $10,000 from your great grandma or something like that, you're gonna make $5,000 in 10 years. See, it's a percentage. This is all based on percentages. So yes, with $100, it's embarrassing. With $100, it's embarrassing. Let's go back twice to $100. But it is $50 is 50% of what you invested. That's one way to think about it. So whatever you put in, you're going to earn 50% on that investment after 10 years. Fair? Questions, comments, concerns? Are we buying this? Correct. That's the most basic kind of compounding. Compounding once a year. So in other words, the money sits there for a year in the bank. Why do the banks pay you interest? Why do you get interest on bank accounts? Anybody know? That tells you how much interest you get. Yes.
So it's not worth the thing you put it in.
That's right. And so why doesn't the bank do like the government does? Hey, you ever get a tax return? I'm not going to teach you much about income tax in here because it doesn't make any sense. Who gets a tax return? What do they give you back when you get a tax return? Exactly what you overpaid, right?
Yeah.
Do they give you any interest on that? Why not?
They're evil.
But they had that money for an entire year. They had more because the system is set up that way, right?
Yeah.
The bank is incentivized. The bank is an agreement with you. The bank is not the government, obviously. The bank is a separate idea. Well, I'm talking about the Fed. I'm talking about individual banks and credit unions, not the Fed. The Fed is the evil entity. But when you invest money in a bank account, the bank takes your money and does stuff with it. And it says thank you by giving you interest when you get it back. So it gives you back your money plus more. That's a way of the bank saying thank you. The IRS should do this with tax returns, but the system is so ingrained now that nobody does it. So yeah, it's a thank you. The interest is a thank you for having your money be able to do stuff with it. Is that fair? Okay, now, that first one, annual compounding. So I'm gonna start a little laundry list on this sideboard up here. That's not the only kind of compounding you can have. So of those 1.04s we just saw. So there were 10 compounds, because we were in for 10 years. 10 compounds, 10 years. So if it's annual, that means we have number of compounds per year. One, exactly, somebody just said it. One. Annual compounding, compounds once a year. So if it's been 10 years, compounds 10 times. 20 years, compounds 20 times. Once a year. But this is not the only way things compound. You can compound, I'm going to look at 3 different ones here, and I give you another one on your homework. The next way I'm going to look at is monthly compounding. So this is, oh, we wish. Oh, my dear friend.
Trying to figure out.
No, I love that. I love this Melissa so much.
Give me your money.
So the key word here in this 4% is it's an annual percentage rate. Annual percentage rate. So you just nailed it, girl. We have to take the 4% and make sure that the consumer gets that 4% over the course of an entire year. This is called monthly compounding. I'm going to write this here. Monthly compounding. This is going to happen 12 times a year. Now, ideally, we would get 4% every month. Ideally. Now, let's think about this. If this kid leaves this money, monthly compounded, in their bank account for 10 years, it compounds 12 times a year. How many compounds is that going to be? 120. 120 compounds. So everybody think that. 12 times a year. So January, February, March, April, May, June, July, August, September, October. 12 times in the first year. 12 times in the next year. 12 times a year after that. After 10 years, that's 120 compounds. If we got 4% every time, I'm just going to throw it up here real quick. I'm going to put a 2 in between that 1 and that 0 up there to see what it would look like. You're laughing because you're doing it too, yes?
Yes.
Okay. Right. It's incredible. Hillary would say, holy crap, we just turned $100 into $11,000. Unfortunately, that isn't how monthly compounding works. Because if you gave somebody 4% every month, you'd be giving them more than 4% a year, would you not? You'd be giving them a lot more than 4% a year. So what the banks do is they take the rate, the APR, and they divide it by the number of compounds and give you that every compound. So I'm going to pull this up real quick, and we're going to have another column on here. We haven't done number 2 yet. We haven't done what's number 3? Number 3, yeah, we haven't done it yet.
I know.
We haven't done it yet. We're kind of in the middle of doing it. The APR for an annual compounding is just R. In this case, 4%. 4% based on what we did. What would the APR be for a monthly compounded account? Take R and divide it by 12. No, it's annual. Think annually. This kid's leaving it in for 10 years, excuse me. But each year, he's only getting 4 total percent, which means we have to take that 4% and spread it out over the 12 compounds. Now, here's the way I look at this. I don't write it out. I just write it as 4% over 12. Or 0.04 divided by 12. I wouldn't even bother, personally, dividing that because it's going to give you what? Like a nasty decimal that keeps going? Is it not? See, but that problem with that is, here's the problem with that. It's 0.03333333. Depending on how many 3's you use, you get different answers out the back. Just leave it as a fraction. 0.04 over 12. That way it uses the exact value. You don't have to worry about rounding. Remember how rounding was giving us so many issues earlier today in the warm-up? You were getting upset because some of you were getting 0.2% off from other people. Don't round. But let's adjust the equation for number 2. So number 1 is right over there, yes? That's number 1. That's compounding once a year. Compounding once a year. Number 2, still investing $100. We're still investing $100, yes? But we're not going to add 4%. we're gonna add 4% divided by 12. Which, I know you all know how to divide, and you're gonna get pissed off by that, because that means we're getting less percentage. But, we're getting more compound, because we're no longer just doing 10 compound, we're doing how many? We're doing 120, because every year gets 12. So Josie, I'm not gonna write it out again, but this is going to be 10 times 12, or 120 total compound. 10 years, 12 compounds a year. So I'm gonna rewrite it again with 120 in there. Say that again. Yeah, somebody just said, how did you?
No, how do you do this?
We're gonna learn Desmos here too. Oh, we're gonna learn two things. We're gonna put it into Google, and then maybe we'll do Desmos after the break, because we're coming up on 9 o'clock. Let's figure out how to put this into Google first. Cool, cool, cool?
Yeah.
All right, now you have number one's answer. What was the value for number one? I'm so sorry, friends, I didn't write it down. $148.02. Thank you. I'm gonna put that there, $148. I wanted to make sure we can compare this one to it when we get the answer. Let's do it. Put it in Google. And then we'll do Desmos when we come back. Oh, sorry, those watching at home, I forgot. I wrote the equation over there. There we go. That's what I was just describing. Okay, back to Google. Hannah's question is, how do you put this into Google? Great question. And then after break, we'll do Desmos, because Desmos is even better. Trust me, I don't use Desmos for anything except this stuff. And I hate saying that, because you can do this with spreadsheets, but it's a total pain in the ass with spreadsheets. Way better with Desmos. Okay, here we go. Here we go. Here we go. The equation's going to start looking the same. It's going to start with that 100 right there. That's beautiful right there, $100.
No.
All I'm going to do, dear friends, is I'm going to put a /12 right there. That's all it takes. A /12. Now, I can tell by the looks in your eyes you're pissed off at that. I can tell. I can tell. I can tell. I can. Desmos will make this better. I promise you that.
Yep.
Because you'll be able to see it as the fraction is. See how I wrote it over there as 0.04 over 12? Google won't let you write it as over. It has to write it next to it with a flash. Desmos will let us write it so it looks like what we have. And you can actually see the exponent up high.
It doesn't work.
What doesn't work?
I'm done.
Oh, don't worry. We'll get the Desmos after the break. I promise. I promise. I promise, girl. I promise. We'll do it. I know. It does. Well, don't worry. Yeah, I got you. I got you. We got you. But what is it? Monthly compounding is how much? $149.08? Hillary, I can read your mind from here. Embarrassing.
Why is it,
Natalie.
why is it more for monthly than it is for yearly?
Careful. Natalie, say it again, please, dear friend.
Why is it more monthly than it is yearly?
This was the answer to number 3, right? The answer to number 3 was, how does monthly compounding compare to annual compounding? And the answer is, it's a little bit more. It's about 1% more. The question, I didn't ask this question on the thing, did I? I didn't ask why, but why? Why do you think it's more? And we're going to return to this in the project we do the last day of class. But why is it more, do you think? You have to stop thinking linearly and think exponentially, which I know is hard to do as human beings. I know it's hard to do as human beings.
On Sunday, by your 12, close it off.
Hill?
On Monday, morning.
Actually, believe it or not, that has nothing to do with it because they take the year and split it in 12 pieces. Keep thinking, keep thinking. Any other ideas? Hannah, what are you thinking?
Don't say it.
I'm not saying it.
I think it's more, you just get more compound.
It has to do with the fact of the exponential. May I? Real quick? Oh, Scott, I'm here for everybody first, and then we're going to look at the math.
I was gonna say that's not like an average compound over a year.
Because exponentials don't work that way. When you think average, when your brain thinks average, it's thinking adding up and dividing by. That's what they do with the rate, right? They take the rate, divide it by 12. So it looks like you're getting the same thing every month. But you're not getting the same thing every month. You get a little more each month after, aren't you? A little more, because that's how exponents work. That's how exponential growth works. Remember inflation? You apply the same rate every month, you get more each month. So check this out, Josie. Remember your amazing thing earlier when you, no, I do. When you said, I'm going to swing the camera over here so you can look at this. Real quick, I want to go down a little rabbit hole and then we're going to take a break. Because you're all on it. You're seeing what's going on. Okay, so Josie, annual compound. First question, question number one. Let's suppose this kid doesn't go 10 years. Let's suppose they just go 1 year. Just 1 year. Easy. 1 year, start with $100, inflate it by 4%. It's 100 times 1.04. 1 plus 0.04, right? That's $104. That's how much I get out of it after 1 year. Cool? $104, that's it. Yeah. Let's suppose same kid gets 4%, but is able to get it compounded monthly and leave it. I'm ready to go. And he's compounded monthly for a year. For a year, just not 10 years, just 1 year. How many compounds is that going to be? It's going to be 12, right? So that kid now is going to take that $100, multiply it by 1 plus 0.04 divided by 12, right? To the 12th power. Now watch. What does that equal? What does that equal? Oh, swing the camera, Sean, swing the camera. I'm just going to take that 0 off and make it 12 instead of 120. Is that okay? Dear friends, he got 7 cents more than the other kid, which again is pissant money. But it's more, right? And it has to do with everything you three just said. When you're exponentially growing, the amount it's growing each month is not the same. It increases each month. So even though the percent of 4% is done 12 times, so it's equal to, there's a lot of quote marks in here I'm doing right now, equal to 12%, it's not really equal, excuse me, 4%, I said the wrong thing, equal to 4%, it's not really equal to 4%. It's equal to more like 4.1%. This kid's at, and that's called APY, and we'll deal with that in the last project, which we'll do in a couple weeks. That's the last day of class. We'll wrap up with a project. We'll do it together, break up in partners, and work on kind of a wrap up of all this financial stuff. So if you can get more compounds, get them. So monthly's one way. When we come back from break, because it's 9:04 now, let's take a break, hit pause on the camera, and then we'll come back and we'll look at weekly compounding, and then we'll look at daily as the last one on there. And it's basically just the same thing we just did. It's just how does, and we'll look at decimals. We'll see we'll make decimals work for us, and we'll see which one you like better. You can always do it in Google, but decimals is nice. It's really nice because you get to see your equation as you put it in, and you know you're putting it in right because everything's in the right way. Well, let's take 5. We didn't take 5. Haley, what you got? Let me pause this camera. Now, let's give it a shot. So from Google, just Google Desmos. Looks like some of you have already done it, and some of you might have the app on your phone, which is also good. Desmos is spelled D-E-S-M-O-S. When you Google it, it says beautiful free math, which is the first thing that made my heart sing. I am an educational socialist. I build things and give them away. Gesundheit, been doing it for years. One of my favorite stories. About 5, 6, 7 years ago, there was a woman named Amelia Taylor who taught math at OSU Cascades. Didn't meet her until she got her job at OSU Cascades. She got her job, walked up here, was asking around, is Sean Rule up here? And so they were like, yeah, he's over there in 226. So she comes up, knocks on my door. She's like, hi. I'm like, hey. She's like, I'm Amelia. I work at OSU now. I'm like, oh, hey, how you doing? She's like, I needed to thank you. I'm like, oh, what's up? And she's like, you're the only one that keeps all of your resources on the open web. And when they told me I needed to do a lesson on probability and statistics, I went through all your stuff and stole some of the stuff that I liked and then twisted it around, made it my own, and then did that as my presentation, and OSU loved it. I love giving stuff away. And education, y'all pay tuition. That's enough. Everything else should be free. So when I saw Desmos, beautiful free math, I thought to myself, these are my people. These are my people. Except they know how to code. that's where I fall short. I can do the math. I can't make it look good. So they can make it look good. here, there's a lot of stuff. They also offer a lot of different types of calculators. And actually, I just realized now that we don't need to actually go on this page. They offered it back on the Google search. They were all listed there too. But that's okay. We're here now. They have a graphing calculator, which is great, except we don't need it in Math 105. We do not need this if we're going to be doing any kind of graphing like this. The scientific one is the one we want. For function, all this stuff is not needed. For function calculators are effectively what you have on your phone, and they're not helpful for these formulas because you want to be able to see the entire formula. That's the one that lets you see the entire. Go ahead and click on that puppy dog. Go ahead and click on that puppy dog. Scientific. Boom. Takes you out to a blank canvas. Desmos. You can enter stuff in Desmos now. So the way you enter it is there's this little. You can't really see it because it's blinking off the right there. It's blinking the cursor. You put expressions in here, and then you press enter. If you input them correctly, it shows you the result, and it shows you what it looks like. Correct, not like Google where everything's squished in one line with carrots and things like that. It shows you what it actually looks like the way we've been writing it over here. So can we do two things? Let's go back and do both questions 1 and 2 again. And then we'll move on to questions 4 and whatever else is left on the notes for today. All right, is that cool? Now, I do know this. I learned this the hard way. Desmos doesn't like the dollar signs. So when you're doing these kinds of expressions, you have to leave the dollar sign off and just realize the number that comes out is in dollars. I don't know why it doesn't like it. That's one thing Google has up on it. It doesn't like currency. So I'm going to start by typing 100. Not 188, 100. There we go. You see that one? Yeah. The screen. Let me shrink the Google window down a little bit so you can see it better. Is that better? Yeah, you can see that now. Okay. Now we're doing number 1 up there. We're going to multiply that by. And I hit times, it puts a little dot. That's the Mathy time sign. Left parentheses, 1 plus 0.04. This is number 1, so I'm not dividing by 12. Not dividing by 12. Right parentheses. Now, the exponent. The exponent. This is something you have to get used to. That guy right there is your exponent button. That little dude right there? Press that and watch what happens to your cursor. Where did it go? It went up. Exactly right. It went up. Oops, shit. There. Now, let's suppose you forget that. Let's suppose you forget that. You can still do Shift caret and it'll pop it up. You can still do Shift caret and it'll pop it up. I just wanted to show you Shift caret like we did in Google, but I just want to show you that button exists too, and then you just put the power right there. Now what's really cool is, as you're typing it, it actually very helpful says your answers show up on this side. And it's very, very helpful. It's telling you right there that's what's going to be your answer. When you press enter, it just enters it in one line. So you can go ahead and press enter now if you want to. Very nice. And there it is. There it is. Now, that probably doesn't look any better than Google did. Because Google was pretty, at that point, nobody was really upset with Google. I think we started getting upset with Google when we started having fractions exactly here. So, let's enter this next one in. This is number 2. 100 times left parentheses. 1 plus. Now, there might be a shortcut for fraction in Desmos. I don't know what it is. But there is a button for it right here. See that button right there? It says A over B. That's the Desmos fraction button. If you click that, it'll then give you the fraction bar with 2 spots that you can put things in. Yeah. And what I love about Desmos too is it also stretches the parentheses so that it doesn't look funny. I love that. Beautiful. Free math. I know, right? Now we just input. Now, right now, it gets pissed off. See that little arrow over on the right side? Right now it doesn't like it because you've input something it can't, it's waiting for you to finish your expression. Better do it. Better do it. 0.04, still pissed. Divided by 12. Okay, now it's not pissed anymore. Because it can do that. It can do that. But we're not done yet. Because we have to take this thing out 120 times. Yes. So, notice where you are. You're in the denominator of that fraction. What I have learned with Desmos is arrow over until you're out or click outside. You got to get outside the parentheses. Does that make sense? So you have to close the parentheses off. Get outside of them. Then you can carry up and go 120. I'm going to stop right there. Make sure we're all following this. Give me a thumbs up if we're following this and we're getting, okay, good. And you can see, it didn't tell you this again, but that's the answer we got, $149.08. Once again, very nice, very nice. Fair? Keep Desmos handy when we go to the back side of this, because you're really going to like it when you have to repeat a calculation and make little tiny changes in it. We're gonna take a look at that in a second. Emerson, answer that question, or are you just just taking it in? Okay, okay. I couldn't tell if you had a question coming or not. Okay, you badasses.
Yeah, I like it too.
Backside. You like it? Desmos is nice because it looks like what the equation should be. Now, when you turn over, don't panic. I put a generalized equation down here at the bottom. Yeah, that's the formula we're actually using over and over again today, believe it or not. And you're going to see it as we go. You can ignore it right now if you don't want to look at it right now. Just fold it maybe like that. Maybe not look at it right away until we get down. Yeah, it's totally fine. Put another piece of paper on top of that's fine too. Number 5. Let's go weekly. Did I skip number 4? No, we did. How did the final balance? Oh, number 1 was the 3%. I forgot about that. All right, number 5. Weekly compounding. Okay, first of all, let's talk about weekly compounding. I just do our little chart over here with the camera. See it? All right, zoom in a little bit. A little something, something. Weekly compounding. Week 7 days, but this means that we get a compound every 7 days. So, how many compounds per year? 52, which is weird. Because there aren't actually exactly 52 weeks in a year. 52 and a day, as Jody just said. But banks treat it as 52. 52. Which means, if you were taking your interest rate, you'd have to divide it by 52. R over 52. In this case, in our case, it would be 0.04 divided by 52. But this is the beautiful part about Desmos. It can handle it. All you got to do is input it in correctly. I know you can do the math. We've done the math for 2 days now. Let it do the math for you now. Let it do the math. Beautiful, free. Can I pull this down? Is that all right? Cool, cool? All right, let's do it. Swing this over. We're still doing 10 years. Yes, I'm still pretending this guy is saving his money for 10 years. Did I not put that on there? Oh, yeah, after 10 years. Yep, after 10 years. Ta-da! Exactly. Oh, ta-da. Oh, hang on.
No, put in.
What's that? That's the one thing now. Hold that, yeah. Hold that thought. Hold that thought.